Assalamualaikum and selamat sejahtera. So we from group 5. Today our assignment is investigation the effect of electromagnetic interference due to radiation emission. So what is radiated emission? Radiated emission refers to the inadvertent dissemination of electromagnetic energy from electronic device into their surroundings. This emission occurs during the operation of various electronic equipment, including computers, radios, and television, among others. Such emissions can interfere with the functioning of nearby electronic device, potentially disrupting communication signals and compromising the performance of affected equipment. So we go for the next, which is radiated emission effect. Radiated emission refer to electromagnetic energy emitted by electronic device or system which can propagate through space and potentially interfere with other device or system. Radiated emissions can affect nearby electronic equipment, communication system, or even cause electromagnetic interference (EMI) in sensitive environments. So we go for next.
Okay, so for the effects and considerations related to radiated emissions, first, interference, which is radiated emissions can interfere with the operation of other nearby electronic devices or systems. This interference can lead to degradation in performance or malfunctioning of affected equipment. So the next effect is shielding, which is shielding techniques such as metal enclosures, conductive coatings, or ferrite beads can be employed to contain and mitigate radiated emissions from electronic devices. Shielding prevents emissions from escaping the device enclosure and affecting surrounding equipment. So last, the frequency range, which is radiated emissions can occur across a wide frequency range from extremely low frequencies, ELF, to microwave frequencies. The frequency range of emissions depends on the operating characteristics of the electronic device or system and the nature of the signals being processed. So next, the potential effects of EMI from ignition coils, which is interference with electronic devices. Strong EMI from an ignition coil can interfere with the operation of nearby electronic devices, such as radios, GPS systems, and engine control units, ECUs. This can cause symptoms such as static on the radio, loss of GPS signal, or engine performance issues. Health concerns, where there is some scientific debate about the potential health effects of exposure to EMI from ignition coils. Some studies have suggested a possible link between long-term exposure to EMI and certain health problems, such as cancer. However, the evidence is inconclusive, and more research is needed.
The next one is result and from the experiment, which will be explained by me, Ahmad Firdaus, and also Badrul Hakim. So from here, this is the result, which is our source is ignition coil. So we have 4 distance, which is 1.5 meter, 1 meter, 0.4 meter, and 0.2 meter. So firstly, we find the rising time for each of the data, and also overall pulse duration, the highest amplitude, and also zero crossing time of the highest pulse, and half full width, which is 50% of the peak voltage that the ignition coil produce. So first of all, the distance between 1.5 meter, we are able to get rising time, which is 100 nanosecond, which is very high. and also the overall pulse duration is 4.9 microsecond, and the amplitude is 0.925, and also zero crossing time 100 nanosecond. For the lowest one is 0.2 meter, which is it will depends on the distance, will affect the result, where the higher the distance for the ignition coil to spark, it will it will uh, it will increase increase ah? Increase what?
Increase,
Decrease ah?
decrease.
It will decrease the rising time, which is 0% to 90% of the peak. So next one is Badal will explain how to get the result from the data.
Okay. This is a result from we take for 1.5 meter distance. As you can see at the graph, we already plot all the result, which is the rising time between 90% to 10%. We also plot the overall pulse duration and the highest amplitude. We already plot at the highest peak, and the zero crossing time of the highest pulse. We basically from the lowest, from the beginning of the waveform, and the decreasing of the waveform to the zero value. So all the plot uh, we have submitted to the graph. So the result we have we have the we transfer to the result table lah. So this is the result from 1.5 meter. Next. So we can see the value from the result of 1 meter is slightly different from the 1.5 meter, because the distance is playing the major result for the like rising time, overall pulse, the highest amplitude, zero crossing time of the highest pulse, and half full weight. So the distance is the main, we can say the main, the reason why we can get the result differently. Okay, next. This is also the same result for 0.5 meter. We can see the result lah. We also plot the highest time rising, overall pulse duration, highest amplitude, zero crossing, and half full weight. Next, please. So this is the last result, which is 0.2 meter. We also conclude the result to the result data, result table. You can see the result table previously. So the conclusion and discussion will explain to the with Tasha and Aisha.
Okay, so for discussion, the behavior of electromagnetic waves in terms of distance and voltage amplitude is notable. Increasing distance leads to decreased rising time, while decreasing distance results in the increased voltage amplitude. Radiated emissions, including those from devices like cell phones and Wi-Fi routers, propagate through air as electromagnetic waves. These emissions can interfere with signals, impacting wireless networks. Next. So, as for the conclusion,
The study highlights the impact of radiated emissions on networks and the variation in behavior of coil ignition sparks with different distances, leading to differences in peak voltage. Concerns about potential health effects due to long-term exposure to electromagnetic interference, or we call it as EMI, from ignition coils exist, with some studies suggesting a link to health problems like cancer, although evidence remains inconclusive. Additionally, strong EMI from ignition coils can disrupt nearby electronic devices such as radios, GPS systems, and engine control units, causing systems like radiostatic, GPS signal loss, and engine performance issues. So that's all from us. Thank you.